Okay, so in this video we're going to take a look at QuickAlign. And QuickAlign is an SA feature that allows you to easily and quickly align instruments and objects to nominal CAD data. So to illustrate it, I'm going to go ahead and import this IGES file that I have on my desktop, and I'll just drag it into the graphical interface. And then I'll go ahead and solid render it, and you'll see that it's just the standard NRK demo CAD part. And I'll also go ahead and add an instrument. In this case, I've got a Ferro Quantum arm here that I'm going to use to demonstrate it. And depending on the settings that you have for in your add instrument options, the instrument's going to come into your job at a pretty arbitrary location. In this case, it's located at x equals 50 inches. And our task here is really to locate the instrument in the graphical view here relative to the part, in the same relative orientation as the instrument and the part are located in the real world. So we're going to use QuickAlign for that. And the first thing I want to do here is turn on Transparent Instruments. If you go to the View menu and select Transparent Instruments, you'll see that now you can view your CAD data and your measurements and any other entities through this semi-transparent instrument that SA draws for us. And that comes in really handy, particularly with QuickAlign, but in any case, you know, you don't necessarily want the instrument to get in the way of the view of your data. So it's a handy function to just leave on. I generally leave it on all the time. I'm going to go ahead and start up the interface. And while that's starting up, there's 3 different locations where QuickAlign can be found in SA. You can find it under Analysis, Best Fit Transformation, Points to Surfaces Objects, QuickAlign to CAD. You can also find it under Instrument, Locate, QuickAlign to CAD. Now those 2 options allow you to pick instruments and objects that you want to transform when you do the locate. The 3rd location is if you actually right-click on the instrument itself and choose Locate from the context menu, you'll see that QuickAlign to CAD is one of the locate methods. Now with this option, when I hit OK, it's not going to ask me for any instruments or objects. So it's basically going to assume the instrument that you clicked on, and it's not going to allow you to transform any objects. So just keep that in mind. The method that we're using right now through the context menu is pretty common, but if you need to locate other instruments and objects, those other 2 menu locations will allow you to do that. So it's important to recognize that QuickAlign works with discrete measurement modes. So whether you're measuring with an arm or a laser tracker or a laser radar, whatever instrument you're using, it should be acquiring single measurements. So you don't want to be in a temporal scan or a discrete or a spatial scan type mode where multiple points are streaming in. You want to be in a discrete measurement mode. So QuickAlign first asks you to pick inspection points on the surface. And you need to use a minimum of 6. If you think of a typical 3-2-1 fit, 3 points to define a plane, 2 points to define a line, and then 1 point to locate that orientation. Those are the 6 points that it's asking for. You can specify more than 6 if you want, a more tightly wound fit. But generally 6 is the minimum that QuickAlign will allow you to use. And you don't necessarily need to use it on a prismatic part such as this. In this case, this part has 3 surfaces that are generally orthogonal and they're flat, but that's not required, and we'll show an example of that where we're basically aligning 2 curved surfaces. So first thing you need to do is just go ahead and double-click where you want to locate the points that you want to measure on the part, and I'll just pick 3 here on this horizontal surface, 2 on this vertical surface, and let's pick 1 right in the center of this surface. Notice the prompt changed so that I can now pick additional inspection points. And just for sake of argument, let's just pick this one here in the corner. So once I've defined all the points that I want to measure, I'll go ahead and hit enter, and the QuickAlign dialog will come up. Now this dialog can be expanded by clicking on this little window icon here, and this will show the details for your fit, including the max deviation, the RMS error, and also the transformation that's going to be applied from the fit. But when you're actually measuring, you can leave it kind of collapsed in order to be able to see your view. Okay, so before I measure, I'm going to go ahead and set up my group. Let's measure this into a QuickAlign group, and let's give it a target name for the first measured target of P1. And then all we have to do is go into a discrete measurement mode, and start measuring. SA will adjust the view for you, and you just need to place the probe, close to the point that you defined, and then just click the button to take a measurement. And you'll see once I've taken points, as each additional point comes in, the fit is recomputed, and the instrument gets closer and closer to the true fit. Now at this point I've measured 6 points for the fit, which is the bare minimum required for the fit. So I can go ahead and click on the little window dialog. We can see that there's of course no error yet. So once you've measured 6 points, you're generally not going to see any sort of error. But if I now go ahead and decide to click the 7th point here that we defined on the corner, you'll see that now we should see an error that's a little bit more realistic. And you notice here the worst error we have is 6/10,000ths of an inch. So if I want, I can go ahead and click this left chevron arrow to go back, and I can scroll through here, and suppose I want to remeasure this 0.6 here. Suppose I thought that was a poor measurement. All I need to do is scroll down to that row and then just go back and remeasure the point. And SA will recompute the fit and give you updated results. So once you've done this, you can go ahead and hit the quick report button and get a quick report of your fit. Or you could just go ahead and accept it. Now when I do that, SA creates this event over here, this QuickAlign event. And first of all, notice that the instrument is indeed located, our measurements are indeed located to the part as we expect. What I can do is, if I go into the Reports menu and choose Add Dynamic Report, this event can be dragged out into the dynamic report. And the dynamic report is basically a what you see is what you get editor. And it allows you to pull out the results of that fit directly into a report. Okay, so another thing I wanted to illustrate was that you don't actually have to measure your data as part of the QuickAlign command. You can actually measure your data ahead of time and then locate it using QuickAlign later. So in order to do this, I've got some points here that I measured with an arm that are located on this CAD part, and I need to locate the instrument to the CAD part. So in order to do that, this time I'm going to choose Instrument, Locate, QuickAlign to CAD, and I'll pick the instrument I want to move by double-clicking and hitting Enter. As for objects to move, I don't want to move any additional objects. I just want to move my instrument and therefore the measurements, and I want to move them to the CAD part. So I'll just go ahead and hit Enter. And now it's asking for inspection points. So what I'm going to do here is, since I already have my measured data, I want to click on the CAD part in the same location relative to where my actual measurements were. And the easiest way to do it is to kind of pick your outside points that define the rough orientation first, and then choose the other points. Because QuickAlign is actually going to locate the points as you assign each measured point to the nominal point. And if you start off without using widely spaced points, it's going to kind of mess up the orientation. It's going to be kind of hard to figure out which points to assign to which locations. So I'm going to start with the points on the outer edge of the part here. So I know I measured a point here, and I measured a point up here near the front of this CAD. I've got another point measured up here, and another one on the side here. And then I've got a point measured up on the top in that corner, and a point measured on the top in this corner. And then I've got a point up here on the canopy of this CAD model. So once I've double-clicked to define all those points, I'll hit Enter. And now it's going to ask me to pick the actual points that are assigned to those nominal points. So all I have to do is click Pick Measurement, and then pick the existing measurement that corresponds to this location on the CAD part. In this case, I know it was this point, so I'll double-click it. And you'll see immediately I get an initial fit. And I'm going to go to wireframe mode so I can see all my points. I'm going to go ahead and pick the measurement for the next point, which I know is this one. I'll pick the measurement for the third point, which I know is this one. And I'll just proceed on through, picking the measurements that are associated with each point. And once I've done that, now notice here that I clicked toward the back end of the canopy, but it looks like this point is on the front end of the canopy. In this case, it's really not going to matter, because as long as this point is associated with somewhere on this surface, as defined by the boundary lines here, then it'll locate just fine. So picking this last point up here won't mess up the fit at all. And so now I'll look, and you can see that the fit's pretty good here. The RMS is 6/10 thousandths. Let's go ahead and accept that fit, zoom in on the part, and we'll see that our points are now indeed fit to the CAD part. And all this was done after I measured the data. So that's a quick look at QuickAlign. I hope you enjoyed it, and I'll see you next time.